Hi, everyone. Thanks for being here this afternoon. When I talk to a lot of people out there, and most people say, I've never heard of Aviatrix. So hopefully I'm letting you in on a big secret today about what we do and how we do it and so forth. So one of the things I like to do is start out a little bit, because I talk to a lot of folks, especially in corporate IT, who are networking specialists. They've been networking specialists for a long time, kind of like me. I've been in networking since networking was big, thick, yellow cables that you had to wrestle like an anaconda into the floor and so forth. So it's been a long time since I've been in it. But if you think back, 15 years ago, 20 years ago, the architecture was essentially built on the physical infrastructure in the data center. Everything you did was based on how you were going to build that. Whether you chose to use Cisco or other products, you were building on that kind of physical architecture. Then maybe 10 or 15 years ago, VMware virtualized compute. A little bit after that, virtualized the network, and that became part of that IT infrastructure. You were still managing the physical infrastructure, but now you were doing a lot of things virtually, whether that was virtual compute or virtual networking. But now we're moving into an area where you have no access to that virtual or physical layer in the cloud, right? You're not talking to it. You're not able to configure it. You're not able to do the things that you used to be able to do. It pretty much started in AWS, of course, where they expose constructs now, and you have to build your architecture based on those constructs. And it's gotten more complicated because now you have multiple clouds, and multiple clouds have different kind of constructs. So you have the AWS constructs, you have the GCP constructs, the Azure constructs, the Oracle constructs. It goes on in terms of those constructs. A lot of them do the same thing. Each one of them has a routing table that's associated with a VPC or a VNet. They're called different things, and they have different ways of actually configuring them. But essentially, they do the same thing. But now you need a multi-cloud network architecture that is going to ride on top of all that, so that it looks and feels, and you can actually do the things that you used to do when you had control of the underlying infrastructure. You can have an abstraction layer that actually allows you to do these things. And this is what we do. And I want to just kind of back up a little bit to make sure that we're all talking the same language. This couple of slides might seem very, very high level, but I promise I'll drill down a little bit into some of this. But we all understand that the infrastructure as a service providers are giving us compute and storage and network capability in their cloud, different ways of doing it. And then inside that cloud, you're able to create what is essentially the new data center, the VPC or the VNet, inside the cloud here. And this is essentially a walled garden that you're going to put this compute, storage, and network in to build out your application environments. And then those VPCs are like data centers. They need to be connected so that you can share the applications across multiple data centers. Now, the cloud providers provide you constructs to do additional things, networking and security and operations and extensions to all of this stuff. But as AWS says, go build. These are essentially the tools that you're able to work with. So your DevOps teams, for instance, have proven that you can do some of these things in the cloud. They've stitched things together and they've made it work. They love those kind of tools. But as corporate IT starts saying, OK, we need to actually move into the cloud, and we need to bring the corporate governance and the regulatory compliance and everything that we've done in the physical data center, we need to bring that into the cloud. This needs to be made easier. You can't go and do all this significant assembly required stuff over and over again. So this is where Aviatrix comes in. We build this intelligent orchestration and control layer that acts as an abstraction layer on top of these constructs. So instead of having to do all of that assembly yourself, or your DevOps guys doing that manually, you have the ability to do this in a much more automated way. And of course, that can't be just one cloud. We have to take advantage of the underlying infrastructure, the underlying constructs in multiple clouds so that that abstraction layer goes across multiple clouds. It's embracing the native construct. So it's important to understand we're not taking something that was built for the data center and putting it on a VM and sticking it in the cloud. We're actually using the cloud native constructs and then building on top of those. So embracing them and then extending them to do things that they can't do or to be able to go across multiple clouds. So in the presentation, I'll be talking about some of the advanced networking, the advanced security, the advanced operations, and some of the extensions that we do to give you an idea of some of the things that this new architecture can provide for you. So at the center of all this is the controller. You can think of the controller as essentially the brain of the operations. This is the control plane. It's not in the data plane, so traffic doesn't flow through the controller. The controller is simply making sure that it understands and propagates routes, for instance, to the right places. It understands all of the networking constructs. It understands remote users and those guys coming in and what kind of profile they have. It understands all of these things that have to do across multiple clouds. It's talking to the native constructs, and it's updating things in the native constructs. But it's also talking to our gateway, which is, again, software that runs in the cloud. So both the controller and the gateway is simply, for instance, in AWS, an EC2 instance running our software, right? So this has the ability to do all of the control that I'm going to be talking about. So let's talk about advanced networking and some of the things that we do there. So first of all, we can take the controller, and this is something you just spin up out of the marketplace. It's very easy to spin up in 10 minutes. You can bring this up and can be on a T2 micro. It doesn't have to be a big instance. And with only the native constructs. So for instance, the AWS Transit Gateway, which by the way was something that we actually worked very closely with AWS to build. In the past, we were the transit gateway, and then last year they announced that they were going to deliver this construct, this transit gateway construct. We were the only vendor on stage with AWS because of the capabilities that our controller and our advanced functionalities bring to the transit gateway. So in this case, for instance, just the controller and the native transit gateway, we will propagate the routes out to all the VPCs and to the transit gateway, and we can actually push those routes down to the BGP router that's on the, in the data center at the bottom there as well. We can spin up the transit gateway, we can spin up all of the VPCs and the attachments to those VPCs, and then we automate all of this. So if you add another VPC, we're going to propagate the routes to everywhere it needs to be. If you take one away, we take the routes away. We can also do network segmentation. So we can group different VPCs together and say these are in a security domain and they can't talk to this security domain, which is this group of VPCs. And we do that by simply adding routes or removing routes. So there's either a communication path or there's not. And we can support multiple accounts. So most large enterprises don't have one AWS account. They have multiple AWS accounts. And so we can keep track of that. We can keep track of overlapping CIDRs. We can see everything that's going on and orchestrate the whole thing. Have RBAC so that when people log into the operations terminal, they only have access to their account worth of configurations. Then we add our gateway, and our gateway adds advanced features. Like for instance, today, the transit gateway is a regional construct. You can only use that in one region. You can't connect that transit gateway to the other transit gateway and have the traffic flow through that connection. So our gateways give you the ability to create this connection between two regions. That same gateway gives you the ability to extend into in this case, Google Cloud, or then extend into Azure and build this multi-cloud enterprise backbone. Now remember, this is all an overlay. This is running on top of the cloud infrastructure. So the connection, say, between AWS and GCP, that's going to go across the internet. Now, of course, because this is an overlay, it really doesn't care about the underlay. So if you wanted a 100 gig connection instead of a 5 gig connection, you could go to somebody like Equinix and say, give me a connection into AWS and give me a connection into Google. And now our overlay, under the same management and operational capabilities I'll be talking about, will take advantage of that underlay and give you a 100 gig connection between the two. So let's talk a little bit about security services. So one of the things that we can do, our gateway is multi-personality, let's say. It's the same software. You're going to spin up the gateway to do different things. But in this case, I might use it to replace a NAT gateway, but add FQDN filtering. So if you have a VPC that has applications that need to go get a build package on the internet, and it's got to go out to GitHub, you want to whitelist and say it can only get to GitHub to get its build package. And that'll keep it from establishing, for instance, a rogue connection out to something else and starting to dump data out. So this is a very simple way to secure what's going on in a particular VPC. And this is what we call, distributed egress, distributed secure egress. We can also do this, and I'll talk a little bit later about our integration with Palo Alto Networks, where you could have a centralized egress gateway going through, for instance, Palo Alto Networks at a central location. You'll see that a little bit later. We also have the ability to provide high performance and IPsec encryption. So in most cases, when you're doing IPsec encryption in the cloud, you're getting 1.25 gigabits per second. And that's because you're using one core. We have the ability to support to span across multiple cores and use multiple tunnels, so we can put all those together and we can get up to 30 gig of IPsec encryption between our gateways. Now that can be done gateway to gateway in the cloud, or we actually have an appliance that you can run our gateway software in on-prem if, for instance, you want your direct connect to actually be high speed or high performance IPsec encrypted instead of an unencrypted link there. And then we have Smart SAML VPN. Essentially, this is an open VPN client that supports SAML. So now you can have users that have different profiles, and they'll authenticate against your authentication provider. So if it's Active Directory or it's Okta or it's Duo, it doesn't matter what it is, it's going to authenticate the user. They'll get a SAML token, and then based on that SAML token, our controller will maintain an ACL table for each one of those users. So if somebody who is a partner, for instance, comes in, they have access to the partner VPC, and a contractor gets to the contractor VPC, for example. We also have the ability to have geolocation. So if I've got employees that are all over the world, it will actually use geolocation to find the lowest latency gateway for that access, come through that access anywhere in the multi-cloud network, and be able to get to anywhere else in the multi-cloud network based on that ACL table. And this has the ability to be monitored and logged and so forth. This was actually something we originally did for Netflix, because they needed to have the ability to see that somebody did or didn't have access to, for instance, Disney media content. And then if they did have access, did they actually access it? Did they download it? So they actually use this capability even when somebody's in-house, not just on the road. And now let's talk a little bit about operational controls, because this is, of course, super important, right? We can't just provide connectivity. We have to be able to provide the tools to be able to see what's going on in this multi-cloud environment. So the first thing we do is give you a global view across all your cloud connections and be able to see what the status of that connection is, roll over and get, for instance, what the latency is on that. And this just gives you a global view of what's going on. As you drill down into it, we give you the ability to look at, for instance, security domains. This is actually really difficult to do if you're using AWS consoles to say, what security domain can this thing talk to and who can it talk to, because it gets very complex over time. We give you the ability to drill down and visualize exactly how things are connected and what can talk to what. And then we take that a step further. We have a product or a tool we call Flight Path, right? And Flight Path, what it does is it allows you to go into any VPC and select a resource in that VPC and then go somewhere else in the multi-cloud network, maybe a VNet in Azure, and say, select a resource there, and now ask it, can I communicate between those two resources? Let's say, for instance, can I do an SSH connection to that resource over there? So I put in port 22 and say, can I make that connection? Now, it doesn't actually send a packet across the network. This is the power of a controller. What it does is it actually talks to the controller, who understands exactly every path and what can talk to each other and what security domains are involved, and it will actually show you exactly the path, what routes, what routing tables, everything that it goes through, and it'll either give you a pass, yes, you can do that communication, or no, you can't, and it's because of this particular security domain, for instance. And then it'll give you the UUID of the object that's under management that we know if you need to change that. So if you're going to resolve a problem because somebody can't talk to something, you'll know exactly where to go in order to make that change and be able to allow it. Some of our customers, Jefferies Financials, for instance, loves this because he's used to, this is the network guy, he's used to having the application guys call him and say, can I get connectivity to this shared resource? And he has to figure it out and look at it. He's now providing them role-based access to this tool so that they can check it out themselves very quickly and move on. And then everything that we do can be exported to Terraform. So if you've got your DevOps guys who like to automate things, you have a system that can be used kind of point and click through a UI, or we can export it into Terraform and they can automate everything. The cool thing is that you can always go back to the UI and you have this infrastructure to do it. A few weeks ago, I was talking to a customer here in New York who said, yeah, we had a guy that built like amazing scripts that did all kinds of really cool stuff. And then he quit and he left. And now we don't even know what to do with these scripts. So having that fallback and being able to do things or automate in both directions is a real powerful capability. And then everything we do is through a REST API. So if you wanted to build into the system and be able to, add into a solution in your NOC that you wanted to go to the controller and get information and show it in some way, you have the ability to do that. And this is the API walker, so you can always see, well, what's the call, what's the expected JSON response, and so forth into the system. And then finally, I want to talk about partner extensions, right? So we connect to a lot of different things like Splunk and Sumo Logic and Datadog, and a lot of things that we're taking logs and providing that and being able to present those in the way that you're used to being able to present those. But one specific integration I want to talk about is our integration with Palo Alto Networks, because this really shows the power of being able to have this networking capability, this is advanced networking capability that you have to deal with if you're trying to do this in a native way. So if you have a Palo Alto Networks VM series, and you can see this on the left, and you want to connect that to the native transit gateway, the AWS Transit Gateway will force you to have an IPsec tunnel. Now, a lot of people think that IPsec tunnel is for encryption. It's not. It's just tunneling. But it's the only tunneling that they have. So they don't have GRE, and they need that tunnel to move BGP packets so that the route table in the transit gateway can be updated, right? And then there's still manual operation to get that route table out to all of the VPCs. And then as they load balance via ECMP to these VM series, they force you to have SNAT, which means you lose source address visibility, because they can't pin a route specifically to a VM series or pin a session to a VM series. Now, we solve all of those problems because our controller on the right-hand side here is replacing the need for BGP. We're doing all the route propagation. So we're propagating the routes out to all the VPCs, to the transit gateway, to the VM series, through Panorama. And so because we eliminate the need for BGP, we eliminate the need for the IPsec tunnel. And the IPsec tunnel on that side, on the left side, is slamming the performance of the VM series from 6 gig down to 500 megabits per second. That's a 10x hit, right? By removing that IPsec tunnel, we give you 6 gig to the VM series. And you can see in that VPC, we put one of our gateways. And the personality of this gateway is actually to be able to do load balancing. So in this case, we're pinning the traffic to a particular VM series and getting rid of SNAT. So we automate everything, we 10x the performance, and we allow you to have source address visibility. So really powerful capabilities that we bring to the same solution from a Palo Alto network standpoint, but by fixing the network pieces, we make it much simpler and more powerful. So in the end, looking at the system architecture, right in the middle is the controller. We can spin up native things with transit gateway and so forth. With our advanced networking capabilities, we can now create a multi-cloud network that connects your different clouds together. And then once you have that multi-cloud network, you can connect users and branch offices and IoT devices and things to that network. We have the ability to create the firewall network I just talked about, to do high-performance encryption on any one of those links, and then have the operational capability to manage all of this in a holistic way. So that's the end of my presentation. If you have any questions, I can take them now, or just come see us at our booth, and we'll go through any of the details that you have. Thank you very much for your time.